All right, I was 3 minutes in when I realized there was no audio. So here's take number two. Let's get my head up so it's in the picture a little bit better. There you go. Now you can see the top. I guess you can see the ceiling in the office too. So that's good. It's good. Um, the learning objectives for this section is to use Moore's circle to perform stress calculations. Moore's circle is much easier than the equations that we've been using. So the equations we're looking at, we're kind of looking at these equations. However, we're not really going to use them. We're going to develop a new method so that we don't have to use them. So we'll take that and move forward. Where we are in the course, we're able to use the stress transformation equations to find the stress for any arbitrary angle. And we're also able to find, because we took the derivative as a function of the angle, we can figure out at what angle we're going to have our peaks so that we then could evaluate the stresses there to get the maximums or the minimums. So that's good. But it's a lot of math. And, engineers, we want to make things simple. So the equation that we're working with are these two equations. We've got the equation for sigma n and the equation which is that the normal stress at any arbitrary angle n, where n, that direction, that face, is determined by the theta there. And then we have a similar transformation equation for the shear stress, the shear on the n face in the t direction at where that face is specified by theta. So this all occurred. You got to understand, all of this lecture is based on guys that were around before there was Netflix, because if there was Netflix and YouTube and certainly Disney Plus, none of this work ever would have taken place because there would have been other distractions. But some guy spends some time, some guy named Moore, right, spends all this time, and he says, you know what, if I take those equations, I square them, I add them, and I simplify it a bit, I can get to this. I can get to this equation right there. And that's really cool. You don't see it. I know, but that's, again, he probably stared at this thing for a long time to see it. And when you see it, it kind of jumps out at you, but not really. Here you go. Here's the trick. Boom! That's the equation for a circle. This, I'm going to get my pen. Yep, this is x minus h squared. This is y minus 0 squared. And this whole term here is my radius squared. And that's the equation for a circle. So that's where we get Moore's circle. All right, how does that help us? Well, that's what we're going to talk about. Using that as a backdrop, these directions were written for using Moore's circle so that you can walk through a process and you can come up with the answer to what is going on with this stress cube and how does it coordinate. So these are right out of the book, section 211, where the first thing you're going to do is choose a set of reference axes, and then you're gonna identify your stresses, sigma x, sigma y, and your shear stress. So we've got our stress cube, and we're going to draw our arrows on there, boom, 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 boom. And then I put my shear on there. And like I've been advocating, let's put sigma x is equal to whatever, and sigma y is equal to something. And my shear in the xy direction. My pen is not very crisp today. But let's list those things specifically. That's step 2, identifying them. Then we're going to draw, I almost would like to just show you how to do this. We're going to draw on the coordinate axes the n and and we're going to draw things. We draw our points in, and this is an ordered pair. The normal stress and the negative shear stress on these coordinate axes. And then we put the normal stress and the positive on the right and upward respectively. So I walk you through that. Then we're going to plot our stresses. And then we can draw a line between them, and that gives us the radius of Mohr's circle. We can draw the circle, and then we can figure all this stuff out. So really, you just got to see me do it. So let's get after it. And the best way to get after it is in the next presentation, where we're going to do an example problem. And I'll do that with a document camera, and I will do that on paper. And then once we've done our example problem, I actually want to show you something else. It's no longer theory. This is the theory. We're going to do an example problem. Then there's going to be another presentation on, yeah, but there's software to automate this, so we don't even need to do that. I want you to know the process. I want you to understand it. But there's software that can shorten it for us as well. So that'll be one more presentation on software and using the software. So hope you're doing well, and enjoy the example problem.